I'm Anil Kumar, and now let us further explore solving linear systems. The question here is, provide example of a linear system which could be solved by addition or subtraction. We call this method as elimination method. This is kind of a simple method to eliminate one of the variables. Let's take up an example. Let us say we have a linear system 2x plus y equals to 3, and let's say x minus y equals to let's say 10. Okay, now in this particular case you find that coefficients of one of the variable is same, right, or is opposite, you can say. So coefficient is 1 and minus 1. Now in this case, if I add these two equations, then what happens? By addition, we eliminate y. So we get 3x equals to 13, or x is equals to 13 over 3. So that is how we can find the value of x. Once we find the value of x, we can substitute that and find y also, right? So finding 1 by eliminating a variable just by addition or subtraction is called elimination method. So the method we used here is called elimination, and we did elimination by addition, right? So by addition, and we could do it since we had coefficient of one variable as opposite. So we had opposite coefficient of one variable. So in that case you can eliminate by simple addition. Now let's take another example where we'll use subtraction property, right? So we could have x plus 2y equals to 3, and we could have minus, or let's say we can have plus x, okay, plus x minus y equals to 1. Now in this particular equation, what you notice here is that the coefficient of x is same, right? So what we notice here is same coefficient for x, right? So in such case you can eliminate by subtraction. So you can eliminate x, one of the variable, by subtraction. You get an idea, right? So by subtraction. So if I subtract one equation from the other, let us do, this time we do subtraction. In that case, what happens? X minus x is 0. So you eliminate x. Do you see that? And we get here 3y equals to 3 minus 1, which is 2. And so we get y equals to 2 over 3. Now since you have found what y is, you can always find x, right? So let me continue this time. So x will be equals to 1 plus y, and we know what y is. So we have 1 plus 2 over 3, that is 3 plus 2, 5 over 3. So we get our solution as 5 over 3 for x and 2 over 3 for y. You can do needful for the first case also, right? So in such cases we can perform elimination of one of the variable by simple addition or subtraction. It is important to note that in these cases we were given coefficient of one of the variables as exactly same or opposite. So in those conditions, same or opposite, we can add and subtract. But in case we have an equation which is, let's say, 3x plus 2y equals to 5, and we have x minus let's say y equals to 4. In such cases where the coefficients are not same, what do we need to do? We have to make it same, right? So in such cases we need to multiply at least one of the equation, right? To get the same, multiply to get same coefficient, right, of any variable, any one you choose, right? You can choose x, for example. In that case you're going to multiply the whole equation by 3, then it becomes 3x. Now when they are same, then you subtract. So you do combination of multiplication and this property, right? So that is the third way of doing elimination. which we will discuss in the next video, right? So here what we have learned is that in case we are given variables with same, here we have opposite coefficient, here we have same coefficient. If you are given with same coefficient, you can subtract and eliminate that variable. If you are given opposite coefficients, then you can add and eliminate one of the variables and solve for the other. But in case we don't have that kind of a situation, then you need to multiply, make it same, and then do the previous operation. Do you understand? So 2 steps may be required for elimination of different kind. So we have different elimination methods. So this is elimination by addition or subtraction, and we now learn how to eliminate using multiplication. I hope that helps. Thank you and all the best.